Welcome to section 7.3, solving systems of linear equations by graphing. Hopefully by the end of this, you will be able to solve systems of linear equations by graphing. So what is a system of linear equations? So what we're going to have is more than one equation with more than one variable, and you're trying to solve all of that so that you have a solution that works for all of the equations at the same time. So the solution to a system of equations is a solution to all of the equations in the system. So you're going to get more than one equation with more than one variable, and you're trying to find the variables that work for everybody all at once. Graphically, what that looks like is that the solutions are points on both of the graphs. If you have two graphs, you could certainly have more, but we're just going to start with 2x2s for now. And so it's the intersection of the graphs. So visually, we're going to deal with lines mostly, and so if you have two lines that intersect at a point, you have one solution, and the solution is that point where they intersect because that point is on both of the lines. I just wanted to show you that you can have more than one solution if you have different types of graphs. So if you have like a parabola and a line intersecting, you would intersect maybe at 2 points. So I have those in orange there. So you can see that it is possible to have more than one solution if you have a different type of graph. If you have parallel lines, they will never intersect, which means you will never have a solution that works for both of them. Sometimes you also get essentially the same line on top of each other. So if they are the same line, then you will have infinitely many solutions. It's basically every single point on the line is a solution because it's on both lines since they are like overlapping. They're on top of each other. Okay? So let's try one. Solve the system by graphing. What we're going to do is we're going to graph both lines and we're just going to see where they intersect. So the first line that I have here is 5x minus 3y equals 9. Okay, so I notice it's in standard form, so my gut reaction when I see standard form is, ooh, does it have nice intercepts? So let's see, if I cover up the y's, my x-intercept would be 9/5, which is not very pretty to graph. Let's see, my y-intercept, I would have negative 3y equals 9, so the y-intercept would be negative 3, and so that's a lot nicer. So my y-intercept is the point 0, negative 3, which is a nice point to graph. But with that x-intercept being not an integer, that's not really ideal. So what I'm going to do, so I'm going to take this equation and get it to slope-intercept form so that I can at least use the slope to graph some more points. So I'll subtract 5x from both sides and get negative 3y equals negative 5x plus 9. Divide everything by negative 3. So then you're going to have a positive 5/3 x. And then 9 divided by negative 3 would be negative 3. So again, I have a y-intercept of negative 3, which is consistent with what I thought before. So I can go ahead and plot that. And then the slope is 5/3, so that means to get another point, I could go up 1, 2, 3, 4, 5, and to the right 3. And I can do that a couple of times just so I get some more points. 1, 2, 3, 4, 5 up, and 3 to the right. I also, if I want to, I could go down 5 and left 3 because a negative divided by a negative is also a positive. So I could go down 1, 2, 3, 4, 5 and left 3. Okay, and I think that gives me a pretty good idea of what my line looks like. So I'll connect the dots here to form a relatively straight line. Okay, so now my first equation is graphed. Let's see, the second equation that I have is x plus 2y equals 7. And again, I'm in standard form, so my first reaction is, are there nice intercepts? So let's see here. If I cover up the y's because they would be 0, my x-intercept would just be x equals 7. So that one's actually pretty nice. I would have an x-intercept of 7, 0. It's a nice pretty integer. Let's see, if x is 0, I would have 2y equals 7, so that would be 7/2 or 3.5, which isn't as fun to graph on my graphing paper over here. So let's get this one into slope-intercept form as well. So I'll subtract x from both sides, get 2y equals negative x plus 7, divide everything by 2, So I'll have a negative 1/2 x plus 7/2. Again, we have that 3.5 y-intercept, which just isn't very convenient. That x-intercept was really easy to graph, though. Let's go ahead and graph that. That's 7, 0. And then I can actually use my slope of negative 1/2 from the point that I already have. So if I have a slope of negative 1/2, I can either go down 1 and right 2, but that kind of goes away from the other line, or I could also go up 1 and left 2, which kind of moves me closer. And I could do that again, up 1 and left 2, and you can actually see right here where they share a point. So I will stop because I have found the intersection. So right here is the intersection point. It's at the point 3, 2. So that is my answer, is the point 3, 2. So when x is 3 and y is 2, that's a solution for both equations at the same time. Okay, let's do another one. Example 2, we've got solve the system by graphing. All right. First equation I get to graph is 3x minus y equals 4. Give myself some space over here. So I've got 3x minus y equals 4. Okay. And this one, it's not going to have a nice x-intercept. That would be 4/3. That's not very convenient. The y-intercept's not too bad. It's negative 4. But let's go ahead and get that in slope-intercept form. So if I subtract 3x from both sides, I'll have negative y equals negative 3x plus 4. Then I'll divide everything by negative 1. So that'll be y equals 3x minus 4. And that's a lot easier to graph. I've got a y-intercept of negative 4, so I'll start there. My slope is 3, so I'm going to go up 1, 2, 3, and over 1. I'll do that a couple of times just so that I have a few points to work with. Okay. You also can go down and left, so down 3 and left 1. That's also a way to have a slope of positive 3. I'll connect my dots to form a straight line. All right, the next one that I'm graphing is 6x minus 2y equals negative 4. Okay, let's see here. My x-intercept is negative 4, 6, so negative 2/3. That's not very nice to graph. My y-intercept will be negative 4 divided by negative 2, so positive 2. That's a lot nicer. Let's just go ahead and get this into slope-intercept form since we're going to use the y-intercept anyway. I'll go ahead and subtract my 6x from both sides, so I'll have negative 2y equals negative 6x minus 4, and I'll divide everything by negative 2. So if I divide by negative 2, I'll get y. Dividing the negative 6x by negative 2, I'll get 3x. And negative 4 divided by negative 2 will be a positive 2. All right, so graphing this one, I have a y-intercept of 2 and a slope of 3. So I'm going up 1, 2, 3, and over 1. I can do that a couple of times just to get a good line. I can also go down 1, 2, 3, and over 1, down and over 1, down 3 and over 1. And I don't know if you guys are noticing this, but my lines are not intersecting, and they're not going to intersect because they are parallel. Okay? And you might even notice that before we got graphing because they have the same slope. Okay? So same slope means that they are going to be parallel lines, and parallel lines never intersect. So this is a no solution. That's what that looks like. Okay. Let's try another one. Example 3. Solve the system by graphing. My first equation that I have is 2x minus 5y equals 8. So I've got 2x minus 5y equals 8. And let's see, I've got a nice x-intercept. So 8 divided by 2, I would have an x-intercept of 4. So I could plot the point 4, 0 pretty nicely. Okay. My y-intercept is negative 8/5, and that's not very pretty to graph. So let's just go ahead and get this one to slope-intercept form so I can use the slope to graph some more points. So if I subtract 2x from both sides, I'll have negative 5y equals negative 2x plus 8. And then dividing everything by negative 5, I'll have y equals that'll become a positive 2/5 x, because a negative divided by a negative is a positive, and then 8 divided by -5 will be a -8/5. So now I can use the slope, which is 2/5, to graph some more. So my slope is 2/5. I'm going to go up 2 and to the right 5. 1, 2, 3, 4, 5. I also could go down and left because 2 negatives also make a positive. So down 2 and to the left 1, 2, 3, 4, 5. And I could do that a couple of times. 1, 2, 3, 4, 5. Okay. And I'll connect all my points together to form a nice straight line. Alrighty. The next equation that we are graphing is 4x minus 10y equals 16. So let's see here. I've got an x-intercept. That's pretty nice. 4x equals 16 means that x would be 4. So I have the point 4, 0, which is actually the same x-intercept as I had before, which is kind of exciting. So I know that at minimum we'll intersect at that point, but we should probably double check that they're not the same line as well. Okay, so let's go ahead and graph the rest of that line. Let's see, my y-intercept, it's not going to be pretty. It's going to be 16 over -10, so that's not very nice. Let's go ahead and get that into slope-intercept form. So if I subtract 4x from both sides, I'll get -10y equals -4x plus 16. Then I'm going to divide everything by -10. So that'll be y equals, so if I do -4 divided by -10, that'll simplify to 2/5. 16 divided by -10 will be a negative, that would be 8/5 if I simplify it. And you'll notice this is identical to the equation that we had before. They have the exact same x-intercept, or y-intercept, and x-intercept, the same everything, the same equation. And so these are two lines on top of each other. And so graphically, it just looks like the same line again. Solution-wise, what that means is that we're going to have infinitely many solutions. We're going to have that entire line is our solution. Every single point. So we'll just say it is infinitely many solutions because there are an infinite number of points on that line. Okay? So that's what it looks like to solve by graphing, and this is what those special cases look like. And so obviously there's some limitations to doing graphing, but I think overall it's worth doing. It's a good visualization. So now it's your all's turn. You get to try one and show me how much you've learned.